All right, so today we're going to be looking at applying Pascal's method. The iterative process that generates the terms in Pascal's triangle can also be applied to counting paths or routes between 2 points. So this has implications for mapping software, trying to find the most efficient route to get to a location. So we're going to imagine this sort of made-up situation where we've got an array of letters. You can see each row is a new letter, and it spells out Blaise Pascal. But we would kind of be referring this B here, this top. This would be the equivalent of row 0, and then our L's. This would be our row number 1. And we're wondering how many possible ways could we spell out Blaise Pascal, starting at our B and then moving down row 1, 2, 3, all the way down to the last L of Pascal. So we start at B, and we can either choose, we have one way of choosing to get to this L. I can either go from B down to L. There's only one way to get to that L. So there's a 1 there. And to move down here, there's only one path to get to that L. So that becomes a 1. To move down to my first A, to get to that A, I've got to follow from that first L. There's no other way to get to the A. So there's only one way that I could choose BLA, choosing this first A. If I wanted to choose the second A, well, I could get to the second A by going BLA or B second LA. So coming in this route, there's actually 2 ways to get that one. And again, if I wanted to use the third A, the only way that I can arrive at that third A is with my first B, the right-hand L, and then this A here. There's only one way, one path to reach there. And now I'm just continuing using Pascal's triangle where I'm adding the possible paths. Since there was only one way to get to this A here, but there's 2 ways to get to the second A, in order for me to reach this I here, there's 3 possible ways that I could get there. I could go like so, that's one way. I could go like so, that's the second way, or I could go like so, that would be a third way. So we're just showing the possible pathways of arriving to each letter. And the pattern there is I'm simply adding the numbers above it. So 3 plus 3 is 6. And then once I've hit my S to arrive at this E, that's just going to be a 6 or a 6. Because once I go from to get to my S, there's 6 ways to get to that. So to get to this first E, there's only 6 ways. To the second E, there's also only 6 ways. I continue to add my numbers. So there'll be 6 ways to get to that P, 12 ways here, 6, 6, 6, 6 and 12 is 18, 12 and 6 is 18, 6 here, 6 and 18 is 24, 18 and 18 is 36, 18 and 6 is 24, 18 and 6 is 24, and we'll just scooch on through. 6 and 24 is 30, 50, 60, 50, 60, 48, 108, 120, 90, 210, 228. So if I ended with this L, there'd be 210 ways to end with the first L, 228 ways to end with the second L. So therefore, 210 ways to use first L, 228 ways to arrive at my last L. Therefore, there are 210 plus 228, which is 438 ways to spell Blaise Pascal. Blaise Pascal. with the given array. Oh, I just saw a mistake. This here shouldn't be 24, that should be a 6. These numbers here have to be changed. Coming down this way, there's only 6 ways to get to that S. 24 plus 6 is 30. 60 plus 30 is 90. 120 plus 90 is 210. I was wondering why those numbers weren't the same.
With Mrs. Bennett, please
210.
call 3405 for a telephone call.
420.
Bennett, 3405.
Great. Here we're taking a look at a board game. We've got our checker placed at that square, and we're told that we can either move, we can only move diagonally up the board. So we can either go up to the left or up to the right. So the number of ways that I can reach the end of the board, that I can kind of arrive up to there. I'm going to be moving up. There's only one way to go to reach that square. It's to go diagonally left. One way to reach up to the right. Once I've come up to the top left here in this location, I could have come this path, or I could have come this path. So there's 2 ways to go there, but only one way to move up to the right. As I move up to the right, there's always just going to be one way to move up in that direction. And I continue to sort of follow the pattern. If I can get to that one square, I can move up 2 ways in that direction. And here I can move up 2 plus 1 or 3 ways there. 3 plus 1 is 4. 2 plus 3 is 5. This is going to be 5. 5 plus 4 is 9. 4 plus 1 is 5. So therefore, there are 5 plus 9 plus 5 ways, which is equal to 19 ways to reach top of board. Okay, and finally, we're going to look at one more question. Same concept. Paige is leaving school down here in the bottom right, and we want to know how many ways can she arrive home, assuming that we are following this grid pattern. So if she moves to the left, there's only one way if she takes this route, and only one way if she to move up to this corner here. So those are both arrive at 1. However, to get to this point here, she has 2 ways of getting there, because she could go up first and then to the left, or she could go to the left first and then up to the right. And so we start just following the same pattern. We're going to find that there's only one way that she can get this location. We are assuming, of course, that she's always trying to move closer to home. She'll never backtrack. And we start adding our numbers. So 1 plus 2 is 3. 1 plus 3 is 4. 5 ways here. 1 plus 2 is 3. 4, 5, 6. 1 plus 6 is 7. 1 plus 7 is 8, 9. Now come back here. 3 plus 3 is 6, 10, 15. 15 plus 6 is 21. If there are 21 ways to get to this spot, 21 ways there and 8 ways there, that's going to leave us with 29 ways to get to this corner. And then 29 and 9 is 38. I'm going to pause here and just, well, let me just do this first little section. 6 and 4 is 10. 10 and 5 is 15. 10 and 10 is 20. 15 and 20 is 35. 20 and 15 is 35. 35, 70. And then moving from 70 over here, again, there's only 70 ways. So I'm going to pause that and we find up, we get our final answer. There's 5,122 ways to get home. Okay, so hopefully you'll understand this tomorrow in class.